Assalamualaikum and good day everyone. My name is Muhammad Al-Safwan Mirusli, matrix number AA251174. So today I will be presenting our study on the application of arithmetic and geometric sequence in modeling piston rod thermal expansion.
Wait, what is piston rod? Let's look at them. This is a piston. And this is the rod, or connecting rod. Example of piston rod dot in car engine. And how fast it actually operates. And if the rod keeps doing that, it will go through heat and rest cool, causing it to expand and lead to danger. Now you know. Let's continue.
So, the study focus on two important mathematical concepts, which is arithmetic and geometric sequence. Arithmetic sequence have a constant difference and represent linear growth. And on the other hand, geometric sequence have a constant ratio and represent exponential growth. So, in real life engineering systems, piston rods are exposed to extremely high temperature during continuous combustion. This heat causes the rod to expand. If the expansion exceeds the safety tolerance, it can lead to dangerous engine failure, such as seizure or rod snapping. Therefore, an accurate mathematical model is required to predict this expansion. Okay, so the objective of the study is to apply arithmetic sequence in predicting piston rod expansion. Second, to apply geometric sequence in predicting piston rod expansion. And last but not least, to compare results and discuss which model better represent real-world behavior. Today, I will briefly present the filler table. And the facts: the piston rod start at 100 mm and expand either by 0.8 mm by cycle or by a ratio of 1.008. This happens over several cycles and the maximum safe length is 112 mm. Okay, so for ideas, we use arithmetic and geometric sequence to calculate the rod length at each cycle. We compare both models to see which reach the safety limit faster and use graph to show the change. So next, in learning issues, we focus on understanding sequence, calculating the nth term and total sum, and also applying this concept to engineering problems. We also learn how to learn and also to use Excel. Okay, so last but not least, our action plan includes studying notes, using textbook and online resource, and practicing question. We will also use Excel to create tables and graphs. So that's all about me. Thank you.
Okay, so from now on, I will be presenting about methodology. My name is Nur Muhammad Taufik bin Rubai. My matrix number is AA250007. To settle this problem truly, we found 4 formulas that is suitable for this problem to be settled, which are shown here. Then these are the parameters that we receive. A1 refers to initial rod length, which is 100 mm, and then D refers to constant increase every cycle, which is 0.8 mm, and then we have cycle numbers, and then we have maximum safe limit, which is 112 mm. And lastly, we have R, which is growth ratio, which is 1.008 millimeters. From the parameters, the calculation will be carried out in 2 ways, which is manual and Excel calculations. We will use both arithmetic and geometric sequences formulas to calculate the extension at cycle 15, total extension after 15 cycles, average extension per cycle, and lastly, the first cycle end when Tn more or equals to n, which our set limit. That was for manual calculation. And then we will use manual calculation and Excel calculation to make a table for 20 cycles of Tn and Sn, which are arithmetic and geometric sequence and series. Next, the graph will be plotted using Microsoft Excel for better understanding for the behavior of piston rod expansion. Theoretically, the graph will show a linear graph on all arithmetic sequence and then a constant growth for geometric sequence. This graph will also show the limit of the piston rod before it gets too long and made it dangerous that may break it or damage the system. The graph of Tn versus n is plotted to show how the rod length changes with each cycle, and a graph of Sn versus n is plotted to show the cumulative growth over cycles. The horizontal line is representing the maximum length m, which is 112 mm, included the graph for comparison. And then the graph of both arithmetic and geometric models will be compared for us to analyze the growth or length behavior and which one has the realistic safety piston rod expansion. And so far that's all from me. I will give it to my next member to explain about result and calculations.
Hi, my name is Muhammad Hadi bin Mazlan and my metric number is AA251324. Now, I will present the result and calculation of our study. In this section, we use two mathematical models, which are arithmetic sequence and geometric sequence, to analyze the expansion of the piston rod over several cycles. For the arithmetic sequence, the initial length of the piston rod is 100 mm and it increases by a constant value of 0.8 mm per cycle. Using the arithmetic formula, the piston rod length at cycle 15 is 111.2 mm. The total length after 15 cycle is 105,018 mm. The average length per cycle up to cycle 15 is 105.6 mm. To find the safety limit, we'll calculate the cycle when the piston rod reach the maximum safe length of 112.0 mm. From the calculation, the piston rod reached this limit at cycle 16. The table and graph show a straight line pattern, which means the piston rod expands at a constant rate for each cycle. Using the geometric formula, the piston rod length at cycle 15 is 111.18 mm. The total length of the 15 cycle is 1585.98 mm. The average length per cycle is 105.18 mm. The geometry model shows that the piston rod reached the maximum safe length of 112.0 mm at cycle 15.22. The graph shows a curved line, which means the expansion increases faster as the number of cycles increases. This represents percentage growth instead of constant growth. To summarize, the arithmetic model reached the safety limit at cycle 16. The geometric model reached the safety limit earlier at around cycle 15. The geometric model shows after expansion than the arithmetic model. Therefore, the geometric model is more susceptible to represent piston rod expansion for long-term use. That's all for me. Thank you.
Hi, I will continue with my friend, which is about discussion. But first, my name is Oscar Ocean C. Metric number is AA250005. This discussion basically is about which model that is better for this piston rod problem, which one predicts unsafe condition earlier and the faster growth. Well, as far as our study, we can determine that geometric model has faster prediction and growth. This is because it can predict at 15.22 cycle, while arithmetic predicts at 16 cycle, and geometric model also shows an accurate calculation for growth of long term, while arithmetic model can only calculate growth at short term. Other than that, the result also show about heat affects the material. As far as we concerned, this heat causes the piston rod to experience cumulative expansion. We can assume that the heat effect to be intensified over time due to material fatigue and increasing temperature. Atoms in the metal also gain energy and vibrate more strongly, causing it to go thermal expansion. This process also created micro cracks within the piston rod and contribute to its expansion. Lastly, the factors that may influence the results are material properties that respond differently to heat based on atomic structure, bonding and thermal properties. Basically, this indicates that materials with higher coefficients of thermal expansions expand more for a temperature change, and materials with strong atomic bonds expand less than with weaker bonds. Thermal fatigue refers to repeat cycles causing it to stress and crack, weakening the piston rod and increase deformation risks. This is end of my part. I will pass this presentation to my friend. Thank you.
My name is Muhammad Arifan Afiq bin Rizam. My matrix number AA250155. To wrap this up, we can conclude our main findings. We use arithmetic sequence to track constant changes in the data and the geometric sequence to understand patterns that grow at a specific ratio. Using both methods allow us to see the progression of the data from two different mathematical perspectives. Next, the effect of heat on the piston rod. Regarding the science behind this, our results clearly show how temperature affects the length of the piston rod. As the heat increases, the metal expands, causing the rod to get longer. Our calculation proved that there is a direct link between thermal energy and the physical changes in the mechanical components. Next is reflection on what we learned. On a final note, this project was a great way to see how mathematics apply to real-world science. It's one thing to solve equations in a classroom, but seeing how those formulas help us predict the behavior of a machine makes the math much more meaningful. It shows that math is a vital tool for solving practical engineering problems. In order to ensure the accuracy and credibility of our analysis, we consulted several reliable sources throughout the duration of this study. These include academic textbooks for fundamental theories on sequence and thermal expansion, reputable online resources for technical specification of piston system, and our lecture note, Dr. Nurhaliza, notes which provide the essential framework for this project. All sources used have been systematically documented to support the integrity of our findings. To end our presentation, I would like to thank my friend and lecturer for guiding me through this PBL. Thank you so much, and wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.